Since we have understood why sorting is an important operation and also why we study sorting so extensively in data structures and algorithms, right? Now we'll look into one of the first sorting algorithm, which is an insertion sort. So in the next few lectures, we will explore how insertion sort works internally, and also we'll understand why it is called an insertion sort in the first place, right? So however, before we begin learning the insertion sort or any sorting algorithm, there is an important concept I would like to introduce. So there are two key terms associated with the sorting. The first term is a key, and the second one, which is a satellite data. So these are the two important terms you should learn before learning any sorting algorithm, not only an insertion sort, right? So for any sorting algorithm, we need to understand the two important terms. One is a key and another one is a satellite. Now let me explain what they mean in the real world context so that you can better appreciate their importance when we use them in sorting algorithms. So for that, I just want to take a simple example here. So the example here is, imagine we have a data about products on Amazon or Flipkart, or you can name any e-commerce website, right? So assume that we have a data about the products on these type of the companies. So typically such data is stored in the form of a table, something like this. And again, there is an entire subject in undergraduate computer science called databases. This is one of the very important subject in your undergraduate computer science. And here you will learn how such tables are structured and organized. However, we will not go into that level of detail right now. And as of now, just remember that data is stored in the form of a table, something like this, where we will be having bunch of rows and columns, right? So suppose in the table, I have a columns like ID, product ID, then we have product name, right? Price of the product and the description of the product. So here each row in the table represent information about one such product, right? And what about a column here? The column, or we can also call it as, let me write it down here. So we can call this is a column or a field that represent one attribute of the product, such as ID of the product, name of the product, or price of a product, or the description of a product, right? Now my task here is I want to sort all the products by price. So before that, let's say I have a data something like this. So I have a product 1 and the name of the product is N1 and the price of this first product is P1 and the description about this product is D1. Similarly, I have product 2 and name of the product is N2 and price of the product is P2, then D2, right? So 3, N3, P3 and the description about the third product is D3 and so on. There are some other products also have, right? Now my task here is I want to sort them on the basis of this particular column called a price, right? So this makes a practical sense, right? Many customers prefer to sort the products from lowest price to highest price. Typically most of the customers will do the same thing, right? So even though each product has multiple pieces of an information like an ID, name, description, right? But we are going to sort the entire table based on only one attribute called price here. So from this context, we'll understand the two important key terms, one which is a key and another one is a satellite data. From this context, we'll understand what are these two are. First, we'll understand what is a key. So the key is the attribute on which we perform the sorting operation is called as the key. So in this case, what will be the key? So we are performing the sorting operation on which column or which field or which attribute we are performing. So the name is price here. So in this case, price is the key. Now what about the satellite data? We'll understand more about the satellite data now. All the remaining data that is not part of the key is called as the satellite data, right? So if the price is the key, then what about the remaining fields I have? I have product ID and I have product name, right? And also I have product description, right? So these three fields are considered as the satellite data. For example, I'm just taking the first row, first product information. So P1 is the key. So here I'm just redrawing the same thing here. P1 is the key here. And what about the satellite data? Satellite data is ID1, N1 and D1. Similarly for P2, P2 is the key. And satellite data of P2 is ID2, N2 and D2. So this is an information about the second product. Similarly, I have P3. P3 is the key. And the satellite data of P3 is what? ID3, N3 and D3. So imagine we want to sort our products by price in an ascending order, right? So we know about an ascending order, right? So what about an ascending order? The smallest value will be at the first place, right? And the second smallest will be on the next place and so on like this. So initially I have this table, right? So this table contains the information of product 1, ID of the first product is 1 and the name of the first product is N1 and then P1, D1, right? And so on like this. Now, what is my task? I want to perform the sorting on which column? The name of the column is price. So once we perform sorting based on the price column in an ascending order, the entire table will get changed here. Let's assume that after sorting product 3, right? So the product 3 turns out to be the cheapest product. So assume that this is the cheapest product, right? And the next I have the next cheapest product or the second cheapest product among all the data I have is a P1. Let's say assume this is my second cheapest. Then I have P2 is the third cheapest and so on like this, right? So after performing the operation called a sorting, you can able to see at the first place P3 is the smallest one, then I have P1, then P2 and so on like this, right? So the important point to notice in this table is after sorting, the price column is arranged in an ascending order. This is our goal, right? I want to sort them on the basis of a price column, right? When we sort using the price column as the key, the satellite data, what is my satellite data here? My satellite data is PID, product ID, name of the product and the description, right? These values are also getting rearranged here, right? So it doesn't happen that only P3 or the only price values get rearranged, while the other values like IDs, names and description remain in the original position, right? So that is not happened here, right? So remaining all other values are also rearranged. If P3 is the smallest value, then after sorting the entire row corresponding to the product 3 moves to the top, not just P3 alone, right? So the entire record or entire data, entire information about the particular product got rearranged. So I hope everybody were able to understand by looking at this table, right? So in other words, when a key changes the position during the sorting, the entire record, so this is my record, right? So this is the entire record getting changed or moves together. So the key along with its satellite data, so this is my satellite data. So along with the key, the satellite data also moved together. So this is exactly why understanding the concept of key and satellite data is so important before learning any sorting algorithm. So even though I'm comparing only the prices and I know P3 is the smallest one, but when I move P3 to the first position, I also move all of its satellite data along with it. So that is why it is called as the satellite data, because it moves, let me write it down, it moves along with the key wherever the key goes, the satellite data will also goes together. Now the most important question here is why the term called satellite, right? So that satellite word comes from astronomy. So for example, consider earth and moon. So let's say I have earth and moon. So the moon is the satellite of the earth. Wherever the earth moves around the sun, so let's say I have a sun and earth moves around the sun, the moon also moves along with the earth. So in the same way, wherever the key moves during the sorting, the satellite data moves along with it. So this is a very, very fundamental and simple concept, but it is extremely important before start learning any sorting algorithm. So in the next few lectures, we will build on this understanding to develop the intuition behind that insertion sort algorithm. And also we will look into implementation of that insertion